downfall. Sorry about that. Okay. We talked about how to go back and forth from logarithms to exponential and exponential to logarithmic form. So today we're going to talk about how to manipulate the logarithms. And a lot of those properties kind of relate back to some properties of exponents that we talked about at the very beginning of the summer. So hopefully that will kind of help you make the connection here. So first things first is just, these are just reminding you about things about logarithms, that our base for our logarithms has to be a positive number, that it can't be 0, it's not going to be 1 either, and that whatever we're taking the log of, so in this case our u and v, whatever we're taking the log of also has to be a positive number, okay? This should actually say not b is not equal to 0. This should actually say b can't be equal to 1. Sorry about that. Obviously, it can't be 0 since it says strictly greater than 0. Type O. So sorry. That's the only one we got. We're in good shape. Okay. So, and then we'll have an R down here, which is an exponent, and it has to be real. But just making sure that you remember that these have to be positive numbers that we're taking log of. And that was the very last thing we did yesterday, was we talked about the domain for those logarithms, and that's where this comes in. Okay. So we have 3 rules. Is it important that you remember the names of these rules? No, not really. Is it important you remember how to use these rules? Yes, really. Okay. So these are what I call condensing and expanding rules. Okay. So if I condense something, that means I make it smaller. And if I expand something, that means I make it larger. Okay. So these rules have 2 sides, and we're going to talk about them in just a second. The way I have these written, on the left side here, this is the condensed form. All right. And the right side over here is what we call the expanded form. And you probably could have figured that out without me ever opening my mouth and telling you that, because the expanded form is longer than the condensed form. Yeah, for the most part. Okay. So the rules say that if I have the logarithm of the product of 2 or more pieces, I can split this into the logarithm of the first part plus the logarithm of the second part. If I had 3 parts in here, I could say plus the logarithm of the third part. However many things are multiplied together, that's how many pieces I can add together. Okay, that's all the product rule is. If I have the logarithm of a quotient, then whatever's in the top is going to go first, minus whatever's in the bottom. Okay, and once again, I can have multiple pieces there. I just need to be careful with them. Okay, notice my base is going to be the same here. And then finally, my power rule for logarithm says that if I have a logarithm of a power, I can literally just drag that power down in front and make it a product, okay? So my power can become multiplied times my logarithm. Now, with that in mind, that's going from condensed to expanded. If I go from the expanded side back to the condensed side, if I have the 2 logarithms that are added together, I do have to have the same base, and I can condense those into the logarithm of a product. If I have 2 that are subtracted, I can condense it into the logarithm of a quotient. And if I have a number or a variable multiplied out in front, I can rewrite that so that that coefficient out here becomes my power or my exponent. Okay, so we're going to go from condensed to expanded and expanded to condensed and back and forth between these 2. And so the first several things we do is just literally just like we did with the exponents and logarithms, we're just going to be rewriting these. The reason we do this is so that we can solve logarithmic equations in the best possible way. Sometimes we're going to use this to solve. Sometimes we're going to use this just to simplify and evaluate. So being able to manipulate logarithms for our best use, okay? Condensed form is what we typically like when we get ready to solve equations. Expanded form is what we like when we try to evaluate or simplify. So we're going to be using these. So let's see if we can put them into practice. So the directions here say use the properties of logarithms to expand our expressions as much as possible, and then evaluate if possible without using a calculator. And we'll get to that part last. So the first thing we want to do is expand. So if you go back and look at these properties, we're going from the condensed form to the expanded form. So a product means plus, a quotient means minus, and a power means multiply. Okay? All right. So I'm going to be asking you those questions. So I have log base 4 of x times y. What operation am I going to use to connect my two logarithms for this problem? So I'm going to have a log base 4 of x and a log base 4 of y. And what operation am I going to put in here? Yep, somebody's already answered me. I'm going to add these two, okay? So when I have the product, I'm going to add, right? Okay, doesn't matter what my base is going to go with these. So in number 2 here, I have a natural log. That's a log base e, all right? Remember that. And this is going to be the natural log of e to the 5th and the natural log of r. And what operation am I going to use between these two logarithms? Let me see if I can get a couple more answers too. Make me so happy to hear from 2 people, 3 people, 5 people, 6 people. There we go. Now we're getting it. Excellent. Very good. Okay, getting more answers. That makes me very happy. All right, so I'm going to subtract these two. The quotient becomes the difference here. Now, on the first one, there wasn't anything else I could do. Log base 4 of x is lovely. Log base 4 of y is lovely. I mean, there's nothing I can do. On this one, however, I can simplify, okay? And so this is what we did yesterday. One of the rules, and I'm going to remind you, so here is a reminder. And the reminder said the natural log of e to a power. Does anybody remember what the natural log of e to a power was? It was one of our cancellation properties. I take the natural log of e to a power. What is that going to give me? Somebody go look up in their notes. That's why you have this fabulous set of notes. Yes, that is correct. Okay, yeah, yes, you jumped ahead. Okay, so the natural log of e to a power is going to give me the power there. So I'm going to get x. So that means that the natural log of e to the 5th is going to be 5, right? And so then I have 5 minus the natural log of r. And that is my expanded and evaluated answer here, okay? So when you're doing your homework or taking quizzes and it's either multiple choice or type in answers, if you end up with the natural log of e to a power, you have to simplify that part, okay? Yes, you've expanded it, but you have to simplify that, okay? Excellent. So next, I have the natural log of 5, e to the 2nd power. So what operation am I going to use to connect my two logarithms here? Addition, subtraction, or multiplication. There we go. I'm liking that. Oh, yes, y'all figured out how to use the symbols and everything. Y'all are so good. So I have the natural log of 5 plus the natural log of e to the 2nd power. Now, I can actually simplify this a couple of ways. The natural log of 5, I can only simplify with a calculator. And I can, but the directions specifically said without using a calculator. So I'm not going to do anything with these. Again, I am going back and using this cancellation property here. So the natural log of e to the second power has a value of what? Yep. Anybody else want to chime in? No, y'all are asleep. Need coffee this morning. Yep. Okay. All right. Plus 2. The natural log of e to the second power is 2. Questions? Yes.
To do properties of logarithmics, like expanding the expressions, is it just you take what's outside the parentheses and then add what's in the parentheses to the end of it? Like for the first one, we had log of 4 parentheses xy. Then we had log of 4x plus log of 4y.
Correct. So whatever is in here is going to get split apart. So in this case, we have a quotient here. So that whatever expression's in the top is going to go with the first natural log. Whatever's in the bottom is going to go with the second one. So it's not, but it's almost like a distributive property. It's not, but it's kind of like that. Does that make sense?
Yes, ma'am.
Okay. And I see a question down here in the chat. And I'm really actually glad you asked that. I should have thought about that a while ago. I can't add 5 and 2 here. Okay. So the natural log of 5 is a number, and I could actually punch that into the calculator and get a value there. Okay. But in terms of simplifying it, my answer would be the natural log of 5 plus 2. You could also, if it makes it easier to see that, you could write this as 2 plus the natural log of 5, and that might keep you from feeling the need to add the 5 and the 2. All right, so be really careful there. Okay, just somehow when we see numbers, we think, oh, we can put them together, and we can't. So, okay. So hopefully that makes sense to the person who asked me the question. If not, keep asking. Okay, we're going to see several more of these, and I think it'll make a little bit more sense. So in this next one, we're doing the same kind of thing here. So we're still expanding. All of these problems are asking you to expand. And so here I have a log base 2, and it's going to first go with the top. It always has to go in this order. And then it's going to go with the bottom. And so I have this log base 2 of m. Because it's a quotient, I'm going to subtract. And then I have log base 2 of 32. Okay, so this log base 2 of m, I just can't do anything with that because it's got this variable here and there's just no way to simplify it. However, log base 2 of 32, I can simplify. And if you recall, I'm going to come over here to the side. This is what we did yesterday. Log base 2 of 32 is asking the question 2 to what power is 32? And you can keep doing this in your calculator, 2 times 2 times 2 times 2 times 2 until you get to 32. Some of you may simply recognize this, that 2 to the 5th power is 32. And so my answer here, log base 2 of 32, I can replace with 5. Okay. And again, I can't collect these together. So you could also write this as -5, just don't lose that negative, plus log base 2 of m. So either this answer or this answer is perfectly acceptable. Just don't try to collect those two together. Okay. Questions? Okay, so for number 5, I'm going to give you guys just a minute. I'm not going to ask you to type anything into it, but I am going to give you just a couple of minutes to see if you can take the first step in expansion here. This is a multi-step process on this one because I've got several things going on. So see if you can first split it apart into the difference of 2 logarithms. Okay, so I just want you to split it, first of all, into the difference of two logarithms. And then we'll do it together. And if you think you've got something, you want to share it with me privately, that's fine. That's perfectly fine. If you want to share it with everybody, that's something too. If you're struggling with trying to figure this out, it's okay. Yes. Okay. So if you have something, look up at the screen. If you don't look at the screen. Close your eyes, don't look at the screen, look at your paper, and then look up when you get something. Okay. So at this point, hopefully everybody took this division sign here and remembered it was subtraction. So we took the log of the top one minus the log of the bottom one. Now I want you to notice one of the things that I did here. I wrote this 100y to the third in parentheses because it all goes together, and that's going to be important in just a second. Okay. So I'm going to take this an extra step in here. This first part, this log of the square root of x, I'm going to rewrite this as x to the 1/2. Now that might not be something you thought about doing, but we do have to do that. My square root is the same thing as the 1/2 power. That's going to be huge, okay? Minus, notice that I still have the logarithm of a product, okay? So here's what I want you to do. We're going to put this in parentheses and write this as the log of 100 plus the log of y to the third power. Okay. Now, why did I put it in parentheses? And that's because I've got two pieces here and I need to make sure that I've separated this out and that my negative sign goes with both of these. Okay. Ooh, close. All right. So I'm getting some answers down here where y'all are working on expanding these. So let's look and see what we can do with this, okay? Because we can continue working on this and everything is really good. So this is going to be, my 1/2 is going to come down here in front. So I have 1/2 times the log of x minus, and I see somebody has figured this part out, the log of 100, which we're going to do something with in just a second, okay? And then this is going to be minus the log of y to the third, all right? So now I can't do anything with the 1/2 times the log of x. What is the base on this logarithm? You may remember what the base on this logarithm is? Yeah, the base on this logarithm is 10. And so I've had a couple of people tell me that the log of 100 is 2. 10 to the second power gives me 100. And then I have minus 3 times this log of y. And you can put that y in parentheses. You don't have to, all right? But you can. Questions? The other nice thing about the log of 100, you can actually put that in your calculator. Your calculator will do common logs, the log base 10. So you can do log of 100 and it will also give you 2 if you don't remember that. So 100 is 10 to the second power. And then I have this 3 that comes down in front because it's my exponent. So some of you were close and some of you were spot on. So make sure you're paying attention to what I have here. I couldn't reply to everybody's chats. Questions, because we took a bunch of stuff here to split it apart. This one was a little bit messy. Okay. So now we're going to condense these logarithms. So we're going to take the two pieces or the three pieces or the four pieces or whatever we have, and we're going to squash them back into one. Okay. Notice the directions say be sure to write each expression as a single logarithm whose coefficient is 1. And basically what that means is I'm going to get rid of any numbers in front. So I would not have this 1/2 in front. It would have to go to my exponent. My 3 would have to go to my exponent. Okay, so I would never leave an answer as 3 logarithm of y. Okay, so that's the way I'm making sure. So the very first one is super nice, super friendly. It looks exactly like the right-hand side of the page with the properties, except it's got different letters here, okay? So the sum of two logarithms means I can condense this into the logarithm of the product of A and C. And that's it. That's my final answer. I do encourage you to put that in parentheses. If you've got more than a single term there, I would put it in parentheses, okay? So I have the same logarithm, I'm adding two logarithms together, so that plus becomes that product, okay? Right? So for this one, it's the same as the second little property that we had. So I have the log base 4 because I have the same base. The first one goes in the numerator, and the second one goes in the denominator. So the difference becomes the quotient, right? And then for this last one down here, we're going to condense this into what operation am I going to use because I have a plus here. It's either a product or a quotient. Which one? Somebody help me out. Product or quotient? Yep. Plus becomes my product. Now, watch what happens here. I'm going to put a big parentheses and I'm going to have x minus 2 times x plus 2. Okay. Go ahead and multiply that together. It's just going to make your life easier in the long run. And so I have the log of x squared minus 4. All right. So when I multiply x plus 2 times x minus 2, using FOIL, I just simply get x squared minus 4. That is still going to go in parentheses, though, because I want to make sure anything out there is in parentheses behind my logarithm. Questions? We're doing great. I like single logarithms. Single logarithms are amazing. Okay, so now how to use your calculator for the other types of logarithms, okay? So your calculator you can use for natural logs and common logs, but how would I find log base 4 with my calculator? Because I can't find log base 451 without a calculator. I'm just saying, 4 to a power, a whole number power is never going to be 51. 4 to the second power is 16. 4 to the third power is 64. So somewhere between 2 and 3 is going to give me 51. So how do I evaluate this? I'm going to suggest that you use the natural log, okay? The actual change of base formula says log base A, but I'm going to change this just slightly and tell you always use the natural log. So it's going to be the natural log of whatever this is, so the natural log of u in this case, divided by the natural log of b, whatever the base is, okay? This is a formula. You have to remember this formula. This is the way you're going to be able to do these in your calculator, all right? And now you can actually do this for any of these logarithms in your calculator because I'm showing you how to use this. So to evaluate this, this is going to become the natural log of 51. This number has to go on the top, divided by the natural log of 4. And so then when I put this in the calculator, you're going to have your calculator. So that natural log is that ln of 51, and then divided by the ln of 4. And that should give you, and it says round to 4 decimal places, so 2.8362, which is somewhere between 2 and 3. So that makes sense. Okay. Questions? Make sure you can get your calculator to give you that correct answer. All right, so with that in mind, I want everybody to do number 10, and then I want you to tell me what you got for your answer. This should be something you can type into the chat, super easy. Making sure to round it correctly to 4 decimal places. And if you don't have a calculator, then tell me, I don't have a calculator. And then I'm going to tell you that you have a phone. I just really want to make sure everybody's can use their calculator correctly. I know that sounds silly, but I so don't want you to get on a test and mess this up because the calculator wasn't doing what you thought it was supposed to be doing. And this is the only way I had to know that is for you to tell me what your answer was. So for real, if you don't have a calculator, let me know that so I won't be thinking that you don't know how to do this. Mhm. Okay, I got a couple of people who are still struggling with this. It's okay, we're getting there. So, all right, we're almost there. Making sure. Okay. We're missing a couple of folks. A couple of folks reached me. And what? That could be it. No? Okay. No. All right. Okay, so let's kind of walk through this because I got a couple of people who are stuck on the calculator thing. So, and I want to make sure, like I said, make sure that if you're using this calculator, okay, that you do the natural log and it's going to give you a parentheses. So make sure you close that parentheses behind the natural log of 51 and then divided by the natural log of 4 and make sure you close those parentheses on that, okay, before. And so if you've got this calculator, that's what it should look like before you ever do anything else. So make sure that you've got those parentheses closed on there. And so then you should get, this is for the first problem, okay? Right? So hopefully that will eliminate the problems here. So, okay. All right. So most of you managed to get to the point. I got a couple of folks I still haven't heard from, so I'm not sure. I hope everything's okay. So you should, so this is going to be the natural log of 0.8 or 0.8, it doesn't matter, divided by the natural log of 7. This is, and I had a couple of people who are like, I got a negative. Did I mess up? You did absolutely not mess up. So negative 0.1147, it does round to the 7 here because that was a 6 and then something else. You can get a negative answer. You just can't take the log of a negative number, okay? But you can get a negative answer. Definitely everything's good. Okay? Yay, excellent. All right. So now we're going to talk about what I promised you we were going to talk about, okay? And that is solving equations, both exponential and logarithmic equations. Well, you're like, well, we solved exponential equations. We did, but here is the second method that we're going to use to solve exponential equations. And this method has to do with the fact that I don't have to have like bases, okay? So this method will actually solve even those other exponential equations, and I'm going to show you how that works. We are going to get an approximate solution because we've got some kind of funky numbers going on here. Okay, so it says we're going to actually, write two different answers because some of the homework questions say express your answer in terms of natural logarithms, and then it says give your answer to 4 decimal places. So just beware. Sometimes it's going to ask you for 2 solutions, 2 pieces, so just pay attention to that. We are going to use this little concept. So here's another reminder, okay? And we've already seen this. The natural log of, let's go with A to the x power. Actually, we didn't see this one. Is going to be x times the natural log of A. This is my power rule, remember? So we're going to use this, and we're going to use the natural log of e to the x is just going to become x. So we're going to use these two concepts over the next couple of problems, okay? So we can take the natural log of something to a power, and that power comes down in front of my natural logarithm. And that's ultimately what our goal is here, okay? So let's look at this first problem. We are going to, as long as you do the same thing to both sides of an equation, life is fabulous. We are just solving an equation. And so in the case of this equation, 3 to the x is equal to 5. I'm leaving some space in here. We're going to take the natural log of both sides. Okay? And we're using a natural log because it will go in the calculator. Easy. Okay, and that's the reason we're using the natural log. You could use log base 3, log base 10. You could use log base 5. It doesn't matter. We're using the natural log because it's super easy to go into the calculator. So you take the natural log of both sides, okay? So take the natural log on both sides. That's our directions here, okay? Then we're going to use that power rule. And that means my x here is going to come down in front, x, and then times the natural log of 3 is equal to the natural log of 5. Well, guys, remember what I wanted to solve for? I wanted to solve for x. So how do I solve for x? I divide both sides by everything that's not x, okay? So now I solve for x. So the last step of this is to solve for x. And that means I'm going to get x is equal to the natural log of 5 divided by the natural log of 3. This is my answer in terms of the natural logarithm, okay? So this is going to be my first answer. So if it says express your answer in terms of a natural logarithm, this is my first answer, okay? Now I need to plug this into the calculator to actually figure out what the approximate answer is. So my approximate solution is what happens when I plug this into the calculator. Just like we did on those last problems, we're going to do the natural log of 5, close that parentheses, divided by the natural log of 3, and then that's going to give me 1.4650 because I had a 497 there, right? So 3 to the approximately 1.5 power does give me 5. You can check it, okay? Questions? All right. Number 2. Same thing, exactly the same thing. I'm not changing anything on how I do this. So I have 2 to the x over 3 power is equal to 19. And I'm going to take the natural log of both sides. I just rewrote it so you can see me taking the natural log of both sides, okay? My exponent comes down in front. So this x over 3 comes down in front. So I have the natural log of 2 and then the natural log of 19 on this side. I'm going to solve for x in a two-step process. I'm going to first get rid of this natural log of 2. And so I'm going to have x over 3 is equal to the natural log of 19 divided by the natural log of 2. I still need to solve for x, which means I'm going to multiply both sides by 3. And so that's going to give me x is equal to, and then it's going to be 3 times the natural log of 19 divided by the natural log of 2. And this is the answer in terms of natural logarithms. So just like this was my first answer, this is my first answer, okay? And then this was my approximate answer. And now I'm going to plug this into the calculator to get the approximate answer. Now, this one you do have to be a little bit careful. Make sure you do 3 times that natural log of 19. And make sure you close your parentheses and then divide it by the natural log of 2. and you should get 12.7438. Questions? And this is my approximate answer. So the answer in terms of natural logarithms is considered to be an exact answer. Questions? Questions. All right, hang on a second. No, okay. I'm going to pop in one of those that I put up a while ago. Let's go with that 5 to the x was equal to 625. Okay. Or actually, we'll do the 7 one because that one to me is a little bit harder. So 7 to the x was equal to 343. Okay. Again, we're going to solve this by taking the natural log of 7 to the x. And that's going to be equal to the natural log of 343. Now, based on what we just did, my x comes down in front, and so I have x times the natural log of 7 is equal to the natural log of 343. That means that x is going to be equal to the natural log of 343 divided by the natural log of 7. You plug this into your calculator. I will verify it for you. You're going to get 3. Not if I do that, I'm not. Yep, straight up 3. So, yep, perfect. Okay. So please, please, please know that this is definitely an option. Okay. So those same problems from section 5.1, if you want to go back and work some of them like this, more power to you, it's great. Okay, absolutely nothing wrong with that. Okay. All right. So continuing that concept of solving these, except this is going to use that reminder about the natural log of e to the x is actually going to be x, because these are a little bit nicer problems. Okay, so again, it says solve these exponential equations, expressing your answer in terms of the natural log, and then use a calculator to approximate a solution to 4 decimal places. So we'll have 2 different pieces here. Okay. So just like before, we're going to have e, I'm just going to rewrite this, e to the x plus 7 is equal to 20. And so I'm going to take the natural log of both sides, so the natural log of the left side and the natural log of the right side. And this is why these are my favorites, because these to me are even nicer than the previous ones. Because the natural log of e to the x plus 7, well, I'm going to use this concept right here, and I'm simply left with an x plus 7 over here on the left-hand side, and that's going to be equal to the natural log of 20. That's actually pretty nice. Okay. Now we do have to be careful, because very similar to a question I had a while ago, I'm going to subtract 7 from both sides. You might want to put that minus 7 in front of this natural log of 20 so that you don't try to subtract 20 and 7. Okay, so be careful. So this is the first part of my answer. So this is part A up here. So part A, if we want to label them as A's and B's, and then part B here to use the calculator, we would actually plug this into the calculator. And so again, if you want to put that negative 7 in the front, it kind of probably keeps you out of trouble, and then plus your natural log of 20. However you go about doing it, you should get negative 4.0043. or however you do that, you should get that final answer. So please make sure that you're getting that before we do anything else. And if you're not, let me know, because we have one extra step on number 4. We good? Okay, so I just want some input as to what you might think we need to do as an extra step on number 4. Number 4 requires an extra step, and it's an extra step at the beginning. And I'm kind of open to suggestions. I know what the right answer is, but I'd kind of like to see what you guys think I might need to do on number 4 before I can go about doing everything else. Yes, I see one correct answer. You want to tell me how to do that? Yep. And you want to tell me how to do that? Yes. Okay. So a couple of people, yeah, several people have got the right idea. So before I can do anything else, the first thing I need to do is I need to, y'all both said it greatly, get rid of, move that 150, okay? We do that by dividing both sides by 150. And the reason for this is if you notice on this problem here and on the previous problems, I had a something to a power all by itself, okay? So I need to get, especially that E, I need to get that E to a power on the side all by itself. So before I do anything else, step number 1 is I divide both sides by 150, okay? And so that's going to give me an E to the x minus 4 power on the left-hand side, and it's going to give me 5 over 150 on the right-hand side. Now you can get a decimal for this, but it's really messy. And so I'm actually going to simplify that. You don't have to. It does simplify to 1 over 30. You don't have to simplify it, just carry it around in parentheses, and that's okay. So now at this point, I can take the natural log of both sides and life becomes a little bit nicer. So I'm going to be left with an x minus 4 on the left side. And then this is going to be the natural log of, put this in parentheses. If you don't, you're going to get in trouble. Guaranteed it's got to go in parentheses. And now to get x by itself, I would add 4 to both sides. Again, I would probably put that 4 in front of that natural log. It probably just keeps you more out of trouble than anything else does. So this is my approximate solution. So this is the answer to part A. And then for part B, we're going to plug that into the calculator. Like I said, even when you put it in the calculator, make sure you put that 1 over 30 thing in parentheses. So, okay. So I'm going to show you what it should look like on, if your screen looks like this, it should look like this before you type it in. And then you're going to get x is approximately 0.5988 is my final answer. And that's my approximate value. Questions? So this natural log concept with exponentials will solve, like I said, all of your exponential equations. The method we talked about yesterday in section 5.1 only solves a small group of them, and because it only solves the ones that you can write with the same base, okay? So the natural logarithm method for solving exponential equations, it's kind of like the quadratic formula for solving quadratic equations. It solves all of them, okay? So it is definitely a fallback, and some people are just like, okay, I don't want to have to stop and think about what to a power gives me this. So the natural logs work, and they will always work. All right. So the next thing we're going to do is talk about how to solve logarithmic equations. And we have two different types of logarithmic equations, of course, because it wouldn't be any fun if we didn't. So the first type of logarithmic equation is the one where I can get logarithms on each side. Okay, it's kind of like the equating the bases method, except it's a whole lot easier for the logarithms. And so I may have to use my condensing properties. So I may have to condense both sides. But if I have, let's say, very simply put, if I have log base 8 of x is equal to log base 8 of 15, then x would have to be equal to 15. That's just about as simple as we can make it, okay? So if my bases are the same, then I take whatever I'm having the logarithm of, and I set that equal to each other. And then I would solve for x, and there's going to be more to it than just saying, hey, x is equal to 15, okay? But like I said, sometimes we have to be able to condense the logarithms on one side in order to be able to do this, okay? So this is method number one. So let's look at some examples of this. So we'll start off here. Now, look at the directions which say reject the values that are not in the domain of the original expression, okay? So we need to figure out what's the domain of the original expression. This will keep you out of trouble. So rational equations we solved earlier in the summer, we had to make sure the denominator was not 0. Radical equations, we had to make sure it didn't give us a negative number. Logarithmic equations, we have to make sure the x value doesn't give us anything negative, okay? So let's find the domain. So the domain of, we don't have to worry about this side because there's no x, is going to be where 2x plus 1 is greater than 0. If you will just do this before you do anything else, okay, x must be greater than negative 1/2, right? This is the only thing we have to worry about. X must be greater than negative 1/2, okay? All right. So I have log base 3 of something is equal to log base 3 of something else. Let's drop the logarithms is essentially what I'm doing. So this means that 2x plus 1 has to be equal to 11. And now I have an equation. I can subtract 1 from both sides. 2x is equal to 10. X is equal to 5. Is 5 greater than negative 1/2? Yes, it is. So this is my solution. Done. See? And you were worried because you thought we were going to have to do all kinds of work to equate those bases. Okay, number 2, we got to do a little bit of work though, okay? Before we can set the logarithm so we can drop the logarithms, I have to clean up both sides, okay? This one I didn't have to. I had a log base 3 equal to a log base 3. Life is great. The first step on this one is to condense both sides. All right. So we're going to use the properties to condense. The first property I'm going to use is I'm going to take this number out in front and write it as an exponent. So this becomes the natural log of x plus 5 squared. Okay. All right. Remember that? On the right-hand side, this becomes the natural log of adding these two together. So I multiply these two, 36. Okay, I'm going to stop here and make sure, because these are the properties we just did at the beginning of class today. Questions. How I got 36, how I got x plus 5 squared. Ask away.
How did you get x plus 5 squared?
Okay, I got a question off of both sides. That's excellent. Okay, so I'm going to answer both questions at once. So one of the condensing properties we had said that if I have, if you go back and think about it, it was log base b of x to a power was the power times log base b. Actually, this was my expanding property. So this side with my exponent in front becomes my exponent, means my number in front becomes my exponent. So this 2 moved here, okay, using this property. The other side, so it said that if I have log base b, I think we used m's, plus log base b of n, this became log base b of m times n, right? And so this 36 here is 12 times 3, and that's how I got 36. Does that make sense in terms of the exponent and the 36? It is one of those little properties. Okay. All right. So at this point, now I have the natural log on both sides, so I can drop my natural logs. So when I drop my natural logs, I'm going to have x plus 5 squared is equal to 36. Once I get the same logarithm on each side and I don't have anything else attached to it anywhere else, I simply can erase them. I mean, it's not mathematically very sound to say that, but I can. Now I have a quadratic equation that I can solve. I can take the square root of both sides. That makes it pretty nice. I get x plus 5 is equal to plus or minus 6. Remember when we solved these before, I told you I would write this as 2 separate equations. So x plus 5 is equal to 6, and x plus 5 is equal to negative 6. Subtracting 5 from both sides, I get x is equal to 1. Subtracting 5 here from both sides, I get x is equal to negative 11. Now, there was one thing that I didn't do to begin with. Let me stop and make sure everybody understands where I got 1 and negative 11. Questions about those? Okay. One of these doesn't work. So in problem number 1, I told you to check your domain to make sure your x values. So in this case, x values had to be greater than negative 1/2. I didn't do that here, okay? Because honest and truly, I just forgot about it because I knew I was going to check it at the end. Basically, what most of you guys do is you forget to find that domain to begin with, okay? So the alternate way, if you can't remember, now if you can remember to find the domain, x plus 5 has to be greater than 0. And if you don't remember to find the domain, you have to remember to check, okay? So to check is a little bit harder. So if I'm going to check, I need to check x is equal to 1. And that means basically I need to plug that 1 in. So I have 1 plus 5 is 6. And so this becomes the natural log of 6, okay? And as long as I get a positive value in here, everything's okay. But I could go further. This one is harder. So the 1 is going to be good. But if I check negative 11, that means I have 2 times the natural log of negative 11 plus 5. And this would mean I have the natural log of a negative 6. And this is bad. Okay, so x is equal to 1 is the only solution. This one does not work. Okay, in terms of checking your domain to begin with, the domain for this equation, the expressions in this equation, says that x plus 5 has to be greater than 0, therefore x must be greater than negative 5. And if x is greater than negative 5, that gets rid of this negative 11. 1 is, but negative 11 is not. I personally think checking the domain first is easier, but it's up to you. But you do have to check that, okay? Questions? Questions? Okay. So again, and it's going to tell you, be sure to reject any values, at least in the homework it's going to tell you. So in this particular problem here, I've got 2 logarithms on the left-hand side, 1 logarithm on the right-hand side. So I only have to condense one side. Right-hand side is beautiful, 1 logarithm. I do have to condense the left-hand side. So step number 1 is I have to condense, in this case, the left side, all right? So 2 logarithms that are added together becomes the product of 2 logarithms. So the log base 2 of x plus 3 times x minus 4. All right, and that's going to be equal to log base 2 of x plus 12. I can't do anything with that right-hand side. I can actually go one step further here, and I probably would. You've got to at some point in time. It's up to you as to when. But when you multiply these 2 together, FOIL them out, I'm going to end up with x squared minus x minus 12. I skipped a step in there. I went ahead and multiplied it together and added my like terms. Okay. So just multiply those together. And now I have, it's really nice. I have the logarithm base 2 on one side and log base 2 on the other side. And so I can drop those logarithms. Okay. Questions as to how I got to this point? Again, I'm using those condensing properties. My condensing property that I'm using is log base b of m plus log base b of n becomes log base b of m times n. That was my condensing property. Took 2 logarithms, made it 1. All right, so now I can essentially drop those logarithms. I have x squared minus x minus 12 is equal to x plus 12. I have a quadratic equation. We've already learned to solve a quadratic equation. We have to move everything to one side and set it equal to 0. X squared minus 2x minus 24 is equal to 0. Okay. Here. And we could have done the domain to begin with. We don't have to. We can do it at this point. So we can do the domain in just a minute. So if you didn't do the domain, I think the domain is the easier way to check. So we're factoring that into x minus 6 and x plus 4, setting each factor equal to 0. I get x is equal to negative 4 and x is equal to 6. Right? Let's do a domain check. We have 3 pieces to check. Okay, so we have x plus 3 is greater than 0, which means that x must be greater than negative 3. I have x minus 4 must be greater than 0, so x has to be greater than 4. And I have x plus 12 has to be greater than 0, so x has to be greater than negative 12. Now I'm going to tell you something on here. These have to satisfy all of these, okay? So as I look at x is equal to 6, it is greater than negative 3, it is greater than 4, it is greater than negative 12. So this one is good. So this is a solution, okay? What about negative 4? Well, negative 4 is not greater than negative 3, so it violates this one, and it violates this one. Okay, so it does fit this one, but it doesn't fit either one of these two, okay? So this is not a solution. This value must be rejected, okay? So we have to reject this value, and we can even make a note. Reject because it is not greater than -3 or greater than 4, okay? So it has to fit all of these. So the only solution to this one is 6. Questions? And remember, you can always say, I don't even know what to ask. I'm just lost. That's not good, but you know. Okay. This one we got to condense both sides. Okay. Let's do this. We're going to do it in pieces. Okay. So the first thing is I've got my exponent and it needs to come and be, I've got my number, it needs to become my exponent. So this is going to become the natural log of x squared, and then minus the natural log of 2x minus 3. I can go ahead and condense this side because I don't have any numbers out in front. This side becomes the natural log of 2x goes on the top over x minus 1 goes on the bottom because it's a subtraction problem. Now I'm going to do the same thing over here on the left-hand side after I move. You can do that all at once if you want to. I just did it in 2 steps. The natural log of x squared over 2x minus 3. And that's going to be equal to the natural log of 2x over x minus 1. All right. Now I have little natural logs and whoosh, they go away. So I'm going to set n sides equal to each other. So that means I have x squared over 2x minus 3 is equal to 2x over x minus 1. Okay. Right. And like I said, you can solve the whole thing first and then go back and think about your domains. That may be the easiest thing to do. Just don't forget to check them, okay? When you have a fraction equal to a fraction, you can cross multiply to solve. So in this case, I'm going to have x squared times x minus 1 is equal to 2x times 2x minus 3. Simplifying, I get x to the third power minus x squared. Y'all might be a little bit concerned about that. It'll be okay. And then 4x squared minus 6x. It is still a polynomial, and so I'm going to move everything over here to one side and set it equal to 0. So this is going to be a minus 5x squared, and then a plus 6x is equal to 0. When I get ready to solve this, I factor the x out. There we go. We have a greatest common factor. See, that's not so bad. Right? And then this is going to factor into an x minus 2 and an x minus 3, which means that I get x is equal to 0, 2, and 3. All right, now comes y'all's turn. Which one or all of these work? So it is your job to figure out what the domain is and which of those we need to reject, if any of them, or if all 3 of them are solutions. So in the chat, I need you to tell me which ones of these are solutions. And if you're not sure, then you can tell me I'm not sure. Or you can say, how do I check? Okay, great. Okay, if you're stuck, so I wrote the inequalities over here. I got those inequalities from each little piece up here where it was the natural log of something and the natural log of something and the natural log of stuff. I said each of these greater than 0, remember? I didn't put 2x in there because that's going to give me the same thing as if I did x. So you can, but you don't have to, right? So if I solve this inequality, I get x must be greater than 3/2. This one means x must be greater than 1. Think about this. Again, if you're kind of struggling with this, think about these numbers on a number line. And I want to show you something about this. So here's 0, here's 3/2, and here is 1. Well, it has to be greater than 0, it has to be greater than 1, and it has to be greater than 3/2. All right. So this is everybody. So if you want to think of it in terms of that, you can sketch each interval on your number line, and you can see that therefore you've got everything has to be in all 3 categories. And so a shorter way to say that is it must be greater than 3/2. 3/2 is 1.5, which means then that my solutions are x is equal to 3 and x is equal to 2. X is equal to 0 is just simply not part of my solution set. All right. Does that make a little bit sense? Kind of, sort of. Not, you can see me a really sad face. Okay. So just when you thought it was safe to go back in the water, we changed this again and we had to go get a new boat. So I said we had two types of logarithmic equations to solve, and one of them was the equation where you have a logarithm on each side and you drop the logarithms. This type of logarithmic equation is one where we have logarithms only on one side and the other side has no logarithms whatsoever, okay? Or we can rewrite it so that one side has no logarithms whatsoever and the other side has logarithms, okay? We do need to make sure we condense any logarithms on one side before we try to do this. And then what we're going to do is we're going to rewrite this back in exponential form. So we're going to go back and do what we talked about yesterday when we were rewriting those logarithms into exponential form. And you wondered why we were doing that other than just to torture you. This is one of the reasons. So in this particular case, I have y is equal to log base b of x. Here's my y. So I'm going to go through and label these. Here's my y. This is what my logarithm is equal to. Here's my b, okay? And here is, this collectively is what I'm calling x in this problem, right? Okay, so I'm going to rewrite this as b to the y. So here's my circle if I wanted to do it like this. So b is not b, b is 2. So my equation becomes 2 to the third power, right, is equal to 4x minus 7, all right? So this to this power is equal to here, right? So whether you do it with the a's, I mean the b's, y's, and the x's, or you make a circle or whatever the case may be, this is the equation you're going to solve, okay? Now, keep in mind, 4x minus 7 still must be greater than 0. So 4x must be greater than 7, and x must be greater than 7/4, okay? So we're going to solve this equation. Get 8 is equal to 4x minus 7. I add 7 to both sides. I get 15 is equal to 4x. I divide both sides by 4, and I get x is equal to 15/4. And 15/4 is larger than 7/4. And so therefore, that is my solution. Okay. So that wasn't so bad. We kind of like these. Yeah. Questions? All right. Here we go again. Now, this negative here, there's nothing wrong with that. Okay, so don't worry about the negative there. We just can't have a negative inside of here. Okay, so again, we're going to take this base to this power and we'll set it equal to this expression. Okay, so on the left-hand side, we're going to have 3 to the negative second power is equal to what's inside over there, which is 2x minus 5. Now, 3 to the negative second power we have to be careful of because this becomes 1 over 3 squared, or 1/9. So 1/9 is equal to 2x minus 5. I know y'all don't particularly like this, but we're going to add 5 to both sides. That gives me 5 and 1/9 is equal to 2x. I'm going to rewrite this over here. 5 and 1/9. I'm just rewriting it. I'm not doing anything magic yet. I really need this to be a fraction. 9 times 5 is 45, plus 1 is 46/9 is equal to 2x. If I divide both sides by 2, that's the same thing as multiplying this side by 1/2, right? And that's going to simplify to 23 over 9. And that is my final answer. You can check it. It does give me nice numbers here. Okay. So just to refresh the domain, 2x minus 5 must be greater than 0. 2x must be greater than 5. X must be greater than 5/2. And 23/9 is greater than 5/2. questions. Not much greater, but it was greater. Okay, so this problem, I have to condense the left-hand side before I can do anything else. I need a couple of folks to tell me what is it going to condense to. I'll give you a hint here. The left-hand side is going to become log base 2 of something. And you can just tell me what this something is going to be. So I'm going to sit back and watch. Okay, so in case y'all haven't figured this out, sometimes when I type in the chat, I can't type well. So I have lots of typos. So I got a couple of correct answers. I'd like to get a couple more. Just simply went to sleep. You're more than welcome to say, I just woke up. I know it's really hard to type in those bases and I know I'm making your life difficult. I'm sorry. Sometimes we're always waiting for somebody else to come up with an answer. Okay. And I felt for y'all yesterday. I was watching a WebEx session at home and my internet was absolutely the pits. And so I thought, oh my gosh, I hope my students are not experiencing this because it was miserable. I just finally gave up and had to send them an email and said, I am so sorry that I just had to leave. So I hope yours is better than mine was. Okay. All right. So I am going to condense these by multiplying these two expressions together. And when I multiply them together, I'm going to get x squared minus 4, okay? So I am going to take x plus 2 times x, or x minus 2 times x plus 2, and that's going to multiply together to give me x squared minus 4, all right? So I have log base 2 of this x squared minus 4 is equal to 5. Now I'm going to rewrite this 2 to the 5th power. So 2 to the 5th power is equal to x squared minus 4. Okay. And so this is going to be 32 is equal to x squared minus 4. I'm going to add 4 to both sides. I get 36 is equal to x squared. Got two solutions, remember. I get x is equal to positive and negative 6. However, one of those does not work. My solution is x equals what? Only. Which one works? Correct. Keep going. Yes. 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 Yes, yes, yes. Yes. Yes, yes, yes. Okay, yes, keep going. Okay, if you're checking your domain, my x minus 2 has to be greater than 0, so x has to be greater than 2. X plus 2 also has to be greater than 0, so x has to be greater than negative 2. It has to satisfy both of these, and negative 6 does not. All right, so it is x is equal to 6 only. Okay, so please note we have to reject x is equal to negative 6 because it doesn't fit either one of these. All right, so just be really, really careful here. All right, last problem, last one. Okay, so again, we need to condense the left-hand side. And like I said, this finding the domain thing you can do whenever you want to. If you want to check the domain before you do anything else, then that's fine. It's really kind of a personal preference. You do need to make sure you're checking it at some point in time because you don't want to end up with those bad numbers. So x must be larger than 2 and x must be larger than negative 1/3. Yeah, I kind of put these on the number line a while ago to help you see. And greater than 2 is the most restrictive. So everything has to be greater than 2. Okay. So condensing the left-hand side here, I get log base 3 of 3x plus 1 divided by x minus 2. And this is all equal to 2 over here on the right-hand side. So once I have condensed everything down to a single logarithm, I can rewrite it. And so when I rewrite it, I get 3 to the second power is equal to 3x plus 1 over x minus 2. Now 3 to the second power is nice, it's 9. And in this particular problem, you can think about this as cross multiplying. You can multiply by your common denominator. Whatever you want to think of doing, this is going to be 9 times x minus 2 is equal to 3x plus 1. Like I said, you can think about this as multiplying both sides by this x minus 2. Right? Those cancel out, leaving you with this. Whatever process your brain wants to go through, 9x minus 18 is equal to 3x plus 1. Right? And then subtracting 3x from both sides gives me a 6x. And adding 18 to both sides gives me 19. And so x is equal to 19 over 6. I know, what a lovely fraction. 19 over 6 is larger than 2. It's 3 point something or other. And so here is my final answer. Questions? Okay, that is the end of chapter 5. So the only thing we have left to cover is chapter 7, section 1, which is systems of equations. X plus y is equal to something, elimination, substitution, that kind of thing. So anyway, and that's what we'll do tomorrow. So if you've got questions, stick around and ask them. If I didn't clarify something for you, stick around and ask me, or ask me in a chat and we'll talk. Otherwise, go work on your homework. Bye.